I'm going to go ahead and walk you through how you can use your graphing calculator for the 6.2 lab simulation. So here we have 4 different athletes that are part of a relay, and we're looking at their individual race times. So for example, we have Will here who has a mean of 9.8 and a standard deviation of 0.9. We're going to assume that all of these students' race times follow a roughly normal distribution. So your calculator can simulate their race times using this random norm function here. And the input for that random norm function is the mean followed by the standard deviation, followed by how many numbers we would like to have returned to us. So we're going to do 50 different days for our simulations. We're going to get 50 different race times. That random norm function is under the math probability menu on the calculator. So I'm going to hit math. I'm going to scroll over to probability, and then I'm looking for option 6, which is random norm. And then I'm going to go with Will first. So his mean time was 9.8, his standard deviation was 0.9, and then I want 50 numbers. I'm going to store that into list 1 in my calculator. And so if you're doing this with a partner, you want to make sure all of your lists end up in the same calculator, because we're going to end up combining them together in just a little bit. So they all need to be in the same graphing calculator. All right, so we're ready to go ahead and do John. So we're going to hit math, again, probability, and then random norm. Again, this is going to give us a normal distribution of numbers with mean of 10.3 and 1.1 for the standard deviation here for John. And he also races 50 times. We're going to store that in list 2. And it might be helpful for you here on your paper to just write down where you're storing everything. So like put a little L1 next to Will, a little L2 next to John, because eventually you're going to go ahead and sketch their histograms once you get all of your simulations in the calculator. So we're going to do the same for Eric. So again, math, probability, random norm, and then Eric's mean time was 9.5. His standard deviation was 1, and again, he raced 50 times. We want to store that in list 3. And finally, we can do the same for Ryan. So again, math, probability, random norm. Ryan's mean time was 11.8, and his standard deviation was 1.4. Again, 50 races, and I'm going to store that in list 4. So now I can use that in answering the rest of these questions here. So in question 2, where you're looking at finding the mean for list 3, you can just do StatCalc 1 variable stats to find that calculation. And then where it says how many of the 50 values were within that 9.5 plus or minus 1 seconds, you're just going to count from that calculator. But we are not going to sort the values that are in the calculator. So just be careful there. You're going to have to go through and either physically count, or you can copy and paste that list. So if Eric was in L3, I could, for example, say L3, I want to store that maybe in L5. And then I can sort L5 to make that easier to count. And again, the sort option would be second, and then stat for the list option. And then under ops, I've got sort A. Again, I can sort list 5. I do not want to sort those first 4 lists. So then I could go into list 5 and I could easily count up how many of the race times were within 1 standard deviation of the mean. You're then going to make graphs for each of those lists and sketch them here. And I would label them for each of the racers. And then we're going to look at the distribution of the whole relay time. So you're going to make some predictions. What do you think that the distribution for the combined racers is going to look like? And what do you think the mean and standard deviation is going to be? And then you're actually going to put their total times into list 5. So you're going to go ahead and you're going to take L1 plus L2 plus L3 plus L4. That's going to take each individual racer's time, add them up, and then we're going to store those in list 5. And now we can use list 5 to fill in this table. So here you're really just running 1 variable stats on each of the lists to find the mean and standard deviation. Remember, variance is the standard deviation squared. Here you're just going to add everything up from the previous columns. And then here you're going to run 1 variable stats on L5. And then you'll use that information to answer the questions below. And then here for parts 2 and 3, you're going to end up doing the same idea here, but you are simulating heights. And so you'll use that random norm function 2 times in this portion, one for the men's heights and one for the women's heights. So you're simulating 50 of each, and it gives you the mean and standard deviation here for the men and women. So here it says men have a mean of 69 and a standard deviation of 2.5. So you would do the random norm function 69, comma 2.5, comma 50 to simulate 50 men's heights. And then you would do the women with their mean and standard deviation and 50 heights. And then you can kind of follow along with the steps here. Again, part 3 is optional bonus. So if you opt to stop at the end of this page here, then that would be the full expectation of the 6.2 lab. But if you'd like the opportunity for a little bit of bonus, part 3 will be your bonus opportunity here. If you are working with a partner, you only need to submit one document. Just make sure that both of your names are on it, and then I'll take care of the transferring the scores in the gradebook. So both of you do not need to submit an individual document.